The year is 1901. Off the coast of Antikythera, a group of sponge divers comes across the wreck of an ancient Roman ship. What they find first isn't gold. It isn't statues. It's a corroded lump of metal, cracked, broken, eaten away by time. At a glance, it looks worthless. But then, they take a closer look. Inside that rusted mass are gears. Dozens of them. Intricate, interlocked, machined with a level of precision that simply shouldn't exist in the ancient world. That raises an immediate question. Who built this? And more importantly, why was it here? For over a century, scientists argued about it. Some called it an astronomical clock. Others dismissed it as a mechanical curiosity. But one detail kept tearing those theories apart. These gears don't match anything known from antiquity. Their ratios are mathematically exact. They track the motion of the moon. They can even predict eclipses. And here's the problem. According to conventional history, that level of engineering wasn't possible at the time. Not even close. So what is this thing? A historical anomaly? Or evidence that we've misunderstood ancient science altogether? And if it wasn't supposed to exist, then who made it? This shipwreck wasn't random. It was a Roman merchant vessel, sunk around 60 BC. On board were Greek statues, luxury goods, glassware, coins, everything you'd expect. Everything makes sense except one object. The device later named the Antikythera mechanism. No blueprints. No written records. No ancient text describing it. But the real anomaly isn't how it looks, it's how precise it is. The gears were cut with minimal error. Some have over 200 teeth. Their ratios aren't arbitrary. They reflect complex astronomical cycles, like the 19-year Metonic cycle. Now the question gets uncomfortable. Who had the mathematical knowledge to design something like this? And why did that knowledge vanish from history? For centuries, the standard timeline of science has been clear. Complex mechanical systems don't appear until around the 14th century, when mechanical clocks emerge in Europe. But this device shows up at least 1,400 years earlier. That's not a small discrepancy. That's a direct contradiction. Either the historical timeline is wrong, or we're misunderstanding what this object really is. And there's another detail that often gets overlooked. Microscopic inscriptions inside the mechanism. Nearly invisible to the naked eye. They aren't decorative. They're instructions. Someone didn't just build this machine. They expected someone else to operate it. So who was that someone? And why has no other device like this ever been found? If this was common technology, it should have left a trail. If it didn't, then it came from somewhere else. For decades, historians tried to downplay the significance of this device. They labeled it a mechanical calendar, a rare artifact, an outlier, a historical fluke. Sounds reasonable, except the data doesn't support it. If it's just a calendar, why does it need more than 30 gears? Why model the moon's irregular, elliptical motion? A simple calendar wouldn't require that level of complexity. If it's just a curiosity, why include astronomical cycles calculated down to the exact day? The Saros cycle, 223 months, to predict eclipses. The Metonic cycle, 235 months, to synchronize lunar and solar time. A curiosity doesn't demand scientific precision. The contradiction becomes obvious. Either ancient engineers didn't understand astronomy at this depth, or they did, and that knowledge has been erased or lost. Both can't be true at the same time. And here's the biggest logical break. No prototype of this machine has ever been found. No early version. No simplified model. No evolutionary steps. It appears fully formed. That goes against how technology develops. Every complex system has intermediate stages. But here, nothing. It's as if someone skipped 1,000 years of engineering progress. Some scholars have tried to link it to Archimedes, a documented genius, known for designing advanced mechanical devices. But there's a problem. No direct evidence. No schematics. No detailed descriptions. Just speculation. So what are we really looking at? A one-off invention far ahead of its time? Or the last surviving trace of a body of knowledge that disappeared? And if that knowledge once existed, why did it vanish without leaving any lineage behind? The answer isn't in speculation. It's in the data. And that data has only started to be decoded in the 21st century. In 2005, an international team was assembled, not historians, but physicists, engineers, and imaging specialists. The effort was led by Tony Freeth and Mike Edmonds. working with Cardiff University and University College London. The objective was straightforward, no speculation, just data. They brought in a technology never before applied to an artifact like this: high-resolution X-ray computed tomography, using systems developed by X-Tech Systems. It could see through centimeters of corrosion without damaging the fragments. As they scanned each piece, the first major discovery emerged. Inside wasn't just a cluster of gears, it was a complete mechanical architecture. Layered, interconnected, a deliberately engineered transmission system. Next came advanced surface imaging, reflectance transformation imaging, developed by Tom Malsbender at Hewlett-Packard. This method revealed inscriptions so fine they were nearly invisible. The result: over 3,000 characters of ancient Greek text. Not decoration, documentation. Operational instructions. Explanations for each dial and each cycle. From there, the team began reconstructing a full 3D model. Every gear, every ratio, every hypothesis had to align with the physical evidence. If it didn't, it was discarded. Then came a critical detail. The gear system didn't move uniformly. It used an eccentric mechanism to replicate the moon's irregular motion across the sky. That's not basic knowledge. It requires a deep grasp of Greek astronomy, especially the models associated with Hipparchus. And here's the key point. They didn't just interpret it, they rebuilt it. Multiple physical replicas were constructed, tested, and compared against real astronomical data. The margin of error? Extremely small, which means this isn't theoretical. It's a working system. And as the pieces fell into place, a conclusion started to take shape. This device isn't what we thought. It's more complex, more precise, and far more disruptive to established history. Because if this conclusion holds, the technological timeline of human civilization needs to be rewritten. So what is it? The Antikythera mechanism is a fully realized analog computer, not in the modern electronic sense, but in the strict physical definition, a mechanical system designed to model and predict astronomical phenomena using mathematical relationships. The missing link lies in its differential-like gearing and eccentric drive system, components that allow the entire mechanism to function as a miniature model of the cosmos. In 2006 and 2008, the team led by Tony Freeth published their findings in Nature. They confirmed that the device contains at least 30 bronze gears, cut with a level of precision highly unusual for that era. Here's how it works. A primary drive shaft represents time. When the user turns a hand crank, the entire gear train moves according to fixed ratios that encode astronomical cycles. For example, the 19-year Metonic cycle is represented as 235 months. The 223-month Saros cycle is used to predict solar and lunar eclipses. The gears combine to display when these events will occur on a rear dial. Even more impressive, the system models the moon's irregular motion using an eccentric pin and slot mechanism. This reproduces orbital anomaly, something not formally described in surviving records until many centuries later. The data is concrete. When reconstructed models are compared with modern astronomical calculations, eclipse predictions are accurate within a few hours for a mechanical device over 2,000 years old. And the evidence doesn't stop there. Between 2012 and 2021, continued work by the Antikythera Mechanism Research Project refined the front display. They demonstrated that the system could show the positions of the Sun, Moon, and even the classical planets, based on Greek cosmological models. Validation came through physical replication. Working builds. Turn the crank, and the indicators move exactly as predicted by ancient astronomy. Repeatable. Consistent. And this is where the historical impact lands. For decades, it was assumed that high-precision gear technology emerged in medieval Europe. But this evidence shows that ancient Greek engineers reached that level as early as the 2nd century BC. That doesn't adjust the timeline. It breaks it. Progress wasn't strictly linear. Knowledge was lost. A technological peak existed and then disappeared. Not because it couldn't continue, but because it wasn't preserved. So the final question isn't, what is it? It's this. How many other technologies like this have been buried by history? If this machine exists, then history isn't a straight line. It's fractured. For generations, we've been taught that science advances gradually, from simple to complex. But the Antikythera mechanism disrupts that model completely. It shows a technological peak that appears early and then vanishes. And the real issue isn't that we didn't know about it. It's that we knew and misinterpreted it. We labeled it an exception, an anomaly, something that didn't require deeper explanation. But the data says otherwise. This isn't an accident. It's the product of a fully developed knowledge system, a scientific culture capable of modeling the heavens through mechanical engineering. So the real question shifts. Not who built it, but what kind of knowledge ecosystem made it possible? And why did that ecosystem collapse? There's an uncomfortable hypothesis here. Knowledge isn't only lost through war or disaster. It can disappear through breaks in transmission. When the people who understand it are gone, the system goes with them. No printing press, no mass replication, no backups. A few generations, that's all it takes to erase a technology. That changes how we look at the present. We assume we're at the peak. But history suggests peaks can be forgotten. And once forgotten, they become impossible. The real insight isn't about the past. It's about now. How much of what we take for granted today will be gone in 1,000 years? And when someone uncovers the remnants, what will they think? That we were advanced? Or that we were just another civilization that understood a great deal, then lost it all? The story of the shipwreck off Antikythera doesn't end on the seafloor. It begins with how we rewrite history. And there may be more machines out there, still underwater, waiting to be found, waiting to overturn another certainty we take for granted.